Artificial Intelligence Doctor. User question. How does room temperature affect the metabolic demand and stress levels on the cardiac tissue in elderly individuals using leadless pacemakers? GPT-01 answer. Room temperature can affect the metabolic demand and stress levels on cardiac tissue in elderly individuals with leadless pacemakers through several physiological mechanisms. 1. Thermoregulation and metabolic demand. Cold environments. In colder room temperatures, the body works harder to maintain its core temperature through thermogenesis, which increases metabolic demand. This could elevate the heart rate and cardiac workload as the body diverts blood flow to maintain warmth in vital organs. Warm environments. Excessive heat can lead to vasodilation and increased cardiac output to dissipate heat. This may place additional strain on the heart, particularly in elderly individuals with compromised cardiovascular systems. 2. Autonomic nervous system (ANS) response. Room temperature impacts the balance between sympathetic, fight or flight, and parasympathetic, rest and digest, nervous system activity. In cold temperatures, sympathetic activation can lead to vasoconstriction and elevated heart rate, while in warm conditions, parasympathetic responses might dominate, leading to changes in heart rate and cardiac output. 3. Electrophysiological stress on cardiac tissue. Temperature shifts can alter the ionic currents and membrane potentials of cardiac cells. While leadless pacemakers regulate electrical impulses, abrupt temperature changes might still influence tissue responsiveness, potentially leading to arrhythmias or stress on the cardiac tissue. 4. Impact on pacemaker performance. Extreme room temperatures could theoretically influence the pacemaker's battery life and electronic components, which might indirectly affect its pacing efficiency. This could add stress to cardiac tissue if the device needs to compensate for suboptimal conditions. 5. Age-related thermoregulatory limitations. Elderly individuals often have reduced thermoregulatory efficiency, which can amplify the effects of room temperature on metabolic demand and cardiac stress. This makes them more susceptible to temperature-induced cardiovascular events. Research directions. Understanding these mechanisms in depth requires clinical studies that measure physiological markers like heart rate and variability, blood pressure changes, pacemaker output adjustments, levels of stress hormones, e.g., cortisol, catecholamines, cardiac biomarkers, e.g., troponins, under controlled temperature variations. By quantifying these factors, we can better determine how room temperature impacts the metabolic and cardiac stress in elderly individuals with leadless pacemakers.